All right, so today we're going to dig into something pretty interesting. Um, Data storage.
It is storage.
But not just any data storage.
No, not at all.
We're talking Facebook.
Facebook, exactly.
Facebook's data storage, which, I mean, you start to think about the scale.
Billions of users
Oh, my gosh.
generating an insane amount of data every single day.
Photos, videos, messages.
Likes, comments, you name it.
It's really unbelievable when you think about it.
It's mind-boggling. And what's fascinating is that, we have some research here from the engineers who actually worked on this.
Right.
And they were facing some serious challenges with their user database, what they call the UDB.
Yeah, and, you think about it, their initial setup was using this system in ODB.
In ODB, right.
And it was struggling, especially when it came to storage space.
Huge problem, yeah.
So if you can imagine, Facebook's data storage is like this massive warehouse, right?
Yeah.
That's constantly expanding.
Constantly, yeah.
And they've got their trusty forklift in a DB, and it's not cutting it.
It's getting overloaded, right?
Yeah.
Because at its core, InnoDB uses what's called a B-tree database structure.
Okay.
And it's kind of like, imagine organizing this massive warehouse with a super complex system of labels and indexes.
Okay.
It works.
Right.
But when you're dealing with Facebook's scale, where you're constantly adding and removing things, it creates a ton of clutter, a ton of inefficiency.
It's like trying to find a needle in a haystack, but the haystack just keeps growing.
Exactly. And the needles are moving too.
Right. Exactly.
And to make matters worse, InnoDB wasn't exactly helping itself in the space department.
Okay.
Its compression, the way it was compressing data, not as efficient as it could be.
Oh, wow.
And then each piece of data had all this extra overhead.
Oh, no.
It's like packing peanuts.
Really?
You get a package, you open it up.
Right.
It's like half of it is packing peanuts. That's what was happening here, taking up unnecessary space.
Yeah.
That's a storage nightmare.
It's a storage nightmare.
That's like me opening up my downloads folder and it's just awful in there.
Oh, yeah.
So what did they do? They came up with this whole MyRocks thing, right?
They realized, okay, we need a complete overhaul.
Yeah.
Like a system specifically designed for this insane scale and the demands of flash storage.
Right.
And that's where MyRocks comes in.
Okay.
And MyRocks is based on something called an LSM tree database.
I will admit I had to Google that a couple of times.
Yeah, it's a mouthful, for sure. But it's a really cool concept.
Yeah.
Basically, if you think about it,
Yeah.
InnoDB was like organizing that warehouse with all those labels and constantly rearranging things.
Yeah.
MyRocks, with the LSM tree, it's like having this super efficient self-organizing system that really optimizes for speed and space.
Less clutter.
Way less clutter. Streamlined.
Okay, less clutter, more efficiency. Way more efficient. And one of the coolest things about MyRocks is how it handles something called write amplification.
Write amplification.
Yeah, write amplification. Well, without getting too in the weeds.
Yeah, please.
It's basically this idea that every time you update something on Facebook, right? It's like adding an entry to this massive ledger, right?
Yeah.
And write amplification refers to the fact that with some systems, even a small update can lead to multiple operations in the background.
Okay.
And that wears down the storage media over time.
So it's like I write something down, I erase it, and then I write it again in the same spot.
Exactly.
Eventually, the paper's going to, wear out.
The paper's going to wear out.
Right.
And flash storage it's super fast.
Yeah.
But it can be susceptible to this, right? Like if you're constantly writing and erasing, it wears it down faster.
Okay.
So MyRocks minimizes those extra steps, extends the lifespan, makes things more efficient.
So it's gentler on the hardware.
Much gentler.
Okay, so it's faster, it's gentler. What about you're talking about storage space?
Oh yeah, storage space.
Yeah.
Huge impact. Switching to MyRocks, Facebook reduced the storage footprint of their UDB by, get this, 62.3%.
Oh, seriously? That's over half.
Over half.
Of their storage.
We're talking massive scale here.
I mean, that's huge. That's got to be saving them a ton of money.
Millions of dollars.
And not just money, but you think about the energy consumption.
Oh, absolutely, yeah.
Yeah.
Sustainability-wise, it's a huge win.
That is wild. I mean, optimizing something as, seemingly simple as data storage has this ripple effect.
It's incredible, right? But I will say, building this thing, implementing it, not a walk in the park.
Okay, so this is where it gets complicated.
Oh, yeah. This is the engineering feat, right?
Right.
Because we're talking about migrating a live database,
Right.
billions of users.
It's like changing the engine on a moving car.
It's exactly like that.
Yeah.
In fact, maybe even harder.
Yeah.
Think about one of the first challenges they ran into was something called secondary indexes.
Secondary indexes. Remind me what that is again.
So secondary indexes, they're kind of like the magic behind those people you may know suggestions on Facebook.
Right.
They help the database connect the dots between users.
Gotcha.
Based on all these factors, right?
Yeah.
But managing those connections on a massive scale.
Right.
Huge undertaking.
Okay.
And MyRocks, their initial approach, caused some bottlenecks.
Oh, so it wasn't all smooth sailing?
Not quite.
So what went wrong?
Well, it all boils down to how MyRocks handles data that's been deleted.
Okay.
See, in the database world, just because you delete something doesn't mean it's gone.
Okay, so like I hit delete on a file, it's still in the trash bin.
Exactly.
Okay.
These remnants, they're called tombstones.
Tombstones?
And MyRocks, or rather RocksDB, which is the engine it's based on,
okay.
it had a bit of a tombstone problem.
Tombstone problem. That sounds scary.
They were clogging things up.
Oh, no.
Every time those secondary indexes tried to connect the dots,
yeah.
they had to sift through all these tombstones, which slowed everything down.
Oh, like I'm trying to find a book in the library.
Yeah.
But I have to check every single one.
And there's a bunch of removed stingers everywhere.
Oh, it's the worst.
Frustrating, right?
Yes.
So they realized they needed a smarter approach to manage these deleted entries.
Okay.
And that's where single delete comes in.
Single delete.
Single delete. It's
Okay.
like a self-destructing message. As soon as the data it's referencing is gone, poof, the marker's gone too.
Oh, okay. So less clutter.
Way less clutter. Much faster lookups because those secondary indexes didn't have to wade through all those tombstones.
Got it. Okay.
But they didn't stop there.
They did it.
No, they're like, we can make this even better.
Okay, so single delete was the first step.
First step.
What's the next?
Deletion triggered compaction, or DTC.
DTC, is that like hitting the defrag button on my computer?
Basically, yeah.
Okay.
There's a built-in cleaning crew
Okay.
that constantly monitors for where tombstones might be piling up.
Right.
And if it detects a potential bottleneck, boom, it triggers this targeted cleanup operation.
So it's like a self-cleaning oven, but for my database.
Exactly. Love that analogy.
Okay, so we got single delete, we got DTC.
They're working in tandem.
MyRocks is running smoothly.
Smoother, faster than ever.
But this is still, we're talking about migrating this massive database.
Live database.
Billions of users.
It's like trying to switch out the engine of a moving car.
Yeah, you did say it was going to be harder than that.
It's really hard.
So how do they even approach that? I mean,
Okay, so they realized
yeah.
can't just flip a switch.
No.
They need to test this in a real-world environment.
Right.
But without disrupting everything.
Right, of course.
So they started with what are called disabled replicas.
Disabled replicas.
Yeah.
Okay. What is a disabled replica?
Okay, so it's essentially a clone of their existing database,
Uh-huh.
but running on MyRocks.
Okay.
But here's the thing. They weren't directly serving user traffic,
Oh. Okay.
so they're not, in the mix.
Right.
But they're still pulling in data through MySQL's replication system. So they're passively receiving updates from the main database.
Okay.
It's like shadowboxing, right? They're practicing, getting up to speed, but no risk to the live system.
So they got MyRocks in training.
Exactly.
Okay, that's cool. But how do they know if it can handle, like, what people are actually doing on Facebook?
That is where MyShadow comes in.
MyShadow.
Yeah, they really like these names.
Okay.
It's like having a fly on the wall for your database.
Okay.
It captures real-time production queries from Facebook users.
So, like, me posting a status update, liking a photo, whatever.
All of it. All that generates database
Yeah,
corn.
MyShadow's just, like, grabbing it all.
Grabbing it all and replaying it on those MyRocks replicas.
Oh, that's smart.
So they're able to compare performance, identify discrepancies.
Okay, so they got their simulator.
Exactly.
They're really putting MyRocks through its paces.
They have to be sure, right?
Yeah.
Because even with all this testing, switching over a live system with billions of users,
Yeah. That's still terrifying.
incredibly risky.
What if something goes wrong?
Data integrity is paramount, right?
Yeah.
They cannot afford to lose data.
Right.
So they developed they call it a data correctness tool.
Data correctness tool.
It meticulously compared the data stored in those MyRocks replicas
Okay.
to the original,
Right.
like side-by-side, row-by-row comparison.
So they were really checking their work.
Meticulously checking their work.
Double checking, triple checking, everything.
Multiple modes, even
Mhm.
one mode, pair mode, compared every single row in both databases.
Okay.
Like, imagine 2 massive spreadsheets.
Yeah.
Making sure every cell matches.
Wow.
And then they had select mode. Use those real user queries that MyShadow captured.
Right.
Ran each one on both systems. Compared the results.
Wow.
If there was even a single bit of difference.
Yeah.
Red flag.
That's a problem.
Absolutely. They were not messing around.
They were not messing around. So did they find anything? Like, were there any surprises during this whole migration?
Oh, yeah. They definitely hit a few bumps in the road.
Oh, really?
Yeah. I mean, migrating a system this complex.
Right.
It's like, navigating a maze.
Okay.
Bound to take a few wrong turns.
Okay. So what kind of wrong turns did they take?
So one of the trickiest things they had to deal with was a feature called gap lock.
Gap lock.
Yeah, gap lock.
Okay.
And this is something specific to InnoDB.
Okay.
And how it handles concurrency.
Concurrency. That sounds familiar.
Yeah, so it's all about managing multiple actions happening at the same time.
Right, like when a million people are trying to update their Facebook at the same time.
Exactly. And somehow it doesn't all come crashing down. So gap lock is InnoDB's way of kind of preventing conflicts when you have multiple actions trying to update the same data.
Okay.
It's like, imagine booking a seat on a flight.
Yeah.
And while you're, picking your seat, the system temporarily blocks off a few rows around you.
Okay.
Just in case someone else is trying to book at the same time.
So it's like to prevent overbooking.
Exactly. Keep things organized.
Okay, so if it works, why change it?
Well, it worked for InnoDB.
Okay.
But MyRocks, remember, it's got that LSM tree foundation.
Right.
And it handles concurrency a bit differently.
Okay. How so?
It's less about, locking things down preemptively.
Uh-huh.
And more about optimistically allowing things to happen at the same time.
Right.
And then resolving any conflicts later.
So it's like 2 airlines with totally different booking systems.
Exactly.
They both work, they're just different.
But they speak different languages.
Okay.
And this is where the friction came in during the migration.
Oh.
Because MyRocks, with its optimistic approach, would sometimes flag errors.
Yeah.
In situations where InnoDB was like, nope, we're good.
Oh, okay. So it's not that MyRocks was doing it wrong.
No. It was just a different perspective.
Different approach.
Exactly. Like a language barrier between the two systems.
A language barrier, okay.
And so they had a couple of options.
Okay.
They could try to, teach MyRocks to understand InnoDB's gap lock.
Uh-huh.
But that's incredibly complex.
Yeah, that sounds like a nightmare.
Like trying to, rewire the entire booking system of that airline.
I don't think that's going to work.
So they went with a more practical approach.
Yeah.
Working with the application developers.
Right.
To adjust the queries that relied on this gap lock behavior.
So they're like, okay, let's just tweak the language a little bit.
Exactly. A bit of code diplomacy.
Ooh, diplomacy, I like that.
Right. And it just goes to show how complex this migration really was.
Yeah.
Because it wasn't just about swapping out one database for another.
Right.
It was about, like you said, understanding how all these systems interact,
right.
Making sure they all play nicely together.
That's incredible. So after all that planning, all that testing, how did the actual migration go?
You know what? It went shockingly smoothly.
Oh, really?
They rolled it out in stages, started by directing some read traffic to the MyRocks replicas just to test the waters.
Right.
And then gradually increased the load until MyRocks was handling everything.
Wow. So did it work? Did it live up to all the hype?
Oh, it exceeded expectations.
Wow.
Remember those numbers we talked about?
Yeah.
The 62.3% reduction in storage?
Yeah, it was like half their storage or something.
More than half.
It's crazy.
And they achieved all of that while maintaining the same level of performance and reliability.
That's amazing.
Oh, and get this.
Yeah.
They even ended up migrating their messenger service to MyRocks.
Messenger, which wasn't even on the same system, right?
Totally different database system. But they saw the success of MyRocks.
Sorry.
And they were like, we got to get in on this.
That's wild. So, I mean, what a success story.
Oh, absolutely. A game changer for Facebook.
Right.
And I think a really important lesson for the entire tech world.
What's that?
That sometimes you got to be bold,
Yeah.
You got to be willing to rethink the fundamentals.
Yeah.
And that's how you get these massive breakthroughs.
So what's next? What's next for Facebook? What's next for data storage? I mean, where do we go from here?
That is the million-dollar question, isn't it? The exciting thing is, who knows what they'll come up with next?
That is true. That is true.
But one thing's for sure, it's going to be fascinating to watch it unfold.
This was awesome. I learned a ton about data storage, about Facebook, about the future of all this stuff.
It's amazing what's happening behind the scenes, right?
It really is. It really is. Well, until next time, folks, keep on exploring, keep on learning, and we'll catch you on the next deep dive.